why people chose 3 phases when they transmit power. Why not 4? And why not 5? Why not 12? And I realized that if you took a 3-phase transmission line and then you took a second one alongside of it and you rotated this one 60 degrees electrically, you could put it inside of the first one. And the circle isn't getting any bigger, but now you have, it would seem, twice the amount of power. You would, in fact, have almost twice the amount of power. Now you have a 6-phase line instead of a 3-phase line, but the voltage per foot between phases is the same because you've reduced the voltage between phases by rotating the electrical angle. If that works for 6, why can't you put another 6-phase line inside of a 6-phase line, rotate it a little more? Now I have 12 phases. If that works, why can't you do it again and again and again until you have a tube that is a conductor longitudinally, a funny material, but it's an insulator circumferentially. It's an anisotropic tube. And if you want an interesting adventure in mathematics, figure out the characteristics of that tube. It's doable. But in a more practical vein, during PTI days, we proposed some serious look at the 6-phase and 12-phase line. It turns out that the gain in power is not proportionate. 6-phase almost doubles 3-phase. 12-phase does not almost double 6-phase, so it's a diminishing return. We actually built, PTI had a test site in Malta, and we actually built, I made a model of it at the time, I still have it, of how a 6-phase tower might look with these blue lines are the insulators. Here's another one with a center conductor. We built such a line, I tested it. It worked exactly as you would predict it, so the math proved itself. Nobody was surprised. And, one got a little excited about it until you realize that a 3-phase line, when it goes into the substation, has 3 circuit breakers to open it, close it. And throughout that substation, there are 3 bus bars that these connect to. With a 6-phase line, there would be 6 circuit breakers and 6 bus bars. 12 phases, there would be 12 circuit breakers and 12 bus bars. So the complexity of coupling it's called a high phase order line, of coupling that into a substation sort of defeats the economics of it. Although periodically people raise the question because it would be possible, for example, it's very easy to couple from 12 phases through a transformer down to 3 phases. But it remains an intriguing concept, probably more useful for power educators than for transmission line companies.